You flip a light switch, and boom, light happens. You plug in your phone, and it charges. It's just magic, right? But if I asked you to explain how that all really works, could you? Yeah, it's a little fuzzy for most of us. Well, that's exactly what we're going to fix today. We're going to build this understanding from the ground up. So let's get into it. Does seeing a bunch of letters and symbols like this make your brain just kind of shut down? I totally get it. You see these in a textbook, you try to cram them in your brain for a test, but what do they actually mean? If you've ever felt lost looking at this stuff, I promise, you are in the right place. Here's the thing, and this is maybe the most important part. The problem isn't you. It's never been you. The real issue is that most of us are taught the subject completely backwards. We get forced to memorize abstract math before we ever get a feel for what's actually happening inside the wires. So in this explainer, we're going to flip that entire script. We'll start with why those formulas are a problem. Then I'm going to give you the one simple water pipe analogy that makes it all click. From there, we'll look at the two basic kinds of circuits, see how this stuff powers your world, and I'll wrap it up with a study hack to make it all stick for good. Okay, first things first, let's really dig into why this topic feels so impossible right from the start. It really all comes down to being given the answers before we even understand the questions. This quote just nails it, doesn't it? Trying to memorize V equals IR without any context is exactly like learning to drive a car without having any idea what an engine is. Sure, you can follow the steps, you might even pass the test, but you have zero intuition for what's going on under the hood. You don't actually get it. All right, now for the good part. The solution. And for this to really work, I need you to do me a favor. For just a minute, forget everything you think you know about electricity. Because this one single analogy, this is the key. This is that aha moment where everything is finally going to make sense. Okay, picture a water pipe. Super simple. The current is just how much water is flowing through that pipe. It's the amount of flow. That's it. In electricity, it's the exact same idea. We're just talking about a flow of tiny things called electrons instead of water. So, current is flow. Got it? So, what makes the water flow in the first place? Well, pressure, right? Voltage is exactly that. It's the electrical pressure. It's the push from behind that gets all those electrons moving. No push, no flow. A bigger push, a bigger flow. It's that simple. Voltage is the push. Now, what if our pipe suddenly gets narrower? It's going to be a lot harder for the water to squeeze through, right? That narrowing, that bottleneck, that is resistance. It's anything that opposes the flow. A really thin wire has high resistance, just like a really narrow pipe. Resistance is the blockage. And here's where it all comes together. Just look at this. That scary formula, V equals IR, isn't some abstract rule anymore. When you use our analogy, it becomes a simple statement of fact. Pressure equals flow times blockage. It just makes sense. Okay, so now that we've got a handle on the core concepts, pressure, flow, and blockage, we can start to see how they play out in the real world. Let's look at the two most fundamental ways you can build an electrical path, or a circuit, series and parallel. First up, we have the series circuit. The best way to think about this is like a single file line. There's only one path. Every single electron has to go through every single thing on the circuit, one after the other. There are no detours, no other options, just one path. A parallel circuit, on the other hand, is completely different. Imagine a river that splits into multiple smaller streams. The current flows along until it hits a fork in the road, and then it divides. Some electrons go one way, others go another way. They have choices. This little chart breaks down the key differences perfectly. In a series circuit, or one path, the current, or the flow, is the same everywhere. But the voltage, the push, gets divided up. You know those old Christmas lights where if one bulb burns out, the whole string goes dead? That's a series circuit. You broke the only path. But in a parallel circuit, like the wiring in your house, the voltage stays the same on every branch, but the current splits. That's why you can run your TV, your lights, and your microwave all at the same time. So why does all this matter? I mean, who cares? Well, this next part connects all of these ideas directly to your wallet. Let's talk about what you're actually paying for on that electricity bill every month. So here's a little secret. You don't actually pay for voltage or current. You pay for energy. Think about it like this. Power is like your speed in a car, but energy is the total distance you've traveled. Your electricity bill is measuring the total distance, the total amount of juice you've used over a whole month, and they measure it in something called kilowatt hours. Let me break that down. 1 unit of electricity on your bill, 1 kilowatt hour, is the amount of energy it takes to run a 100-watt light bulb for 10 straight hours. When you start thinking about every single device in your house in those terms, you finally understand why you were always told to turn off the lights when you leave a room. It really adds up. Okay, we have covered a ton of ground, but how do you make sure you actually remember all this for a test or just for your own brain? I'm going to give you a super simple, really powerful study hack that ties it all together. So instead of just making a boring list of formulas, do this. It's a 3-step process. 1. Write down the abstract formula. 2. Right next to it, write down the simple analogy, pressure equals flow times blockage. And 3, this is the most important part, link it to a real-world object you use every day, like your phone charger. Your brain is wired to remember connections and stories, not abstract letters. This makes that knowledge almost impossible to forget. So there you have it. We went from confusing formulas to a simple water analogy, from abstract theory to the wiring inside your own house. You now have the fundamental building blocks to understand how our entire modern world gets its power. So the real question is, what are you going to do with that? Physics isn't just about passing tests. It's about seeing the hidden rules that run everything around us.